Good morning. This video hopefully will enable you to pick up some hints of how to operate the machine in the most effective way. Bear with us because any training video is a little bit tedious and boring, but we try to make it as interesting as possible. The objective ultimately is to enable you to pick up the shortcuts of how to program and operate the machine in the most effective way. We hope you enjoyed, but do pay attention and make notes of anything that is not very clear, so that we can afterwards discuss these points with yourselves. So enjoy it if you can. Thank you. Formar rapidamente simples programa nas belas peças que a gente produz aqui na fábrica. Então, por gentileza, presta bastante atenção, tenha paciência, assista o vídeo umas 2, 3 vezes e cada pergunta que surgir, faz uma anotação para depois a gente poder rever esses pontos e ter certeza que o operador consiga alcançar o objetivo de explorar o máximo possível a capacidade do maquinário e da tecnologia disponível para vocês, tá bom? Então, câmera rolando no treinamento. Bom dia para vocês.
Looked in the operatives here on how to use the CNC machine. Okay, this is the Intermac compact stone and this is the Series 10 control panel. Now we're going to learn how to turn it on. Okay, first of all we turn on this switch and we wait on the screen for the screen to boot. Okay lads, once the screen has booted we get this display and at the top here it says emergency button pressed. We reset the emergency button and now the display tells us to press the control on. So we press this button here, which is control on. Okay, now the machine is ready for working. Also at the top here, now we press control on, it reads execute axis reset. Now every time the machine has been powered down, it loses information from where it is. So when you turn it back on, it needs to go to a position to know where to count from, okay? Now to reset the axes, we first have to press this key here, which is F4. Once we've pressed F4, we see the menu appear here, which is Intermac. We press the key under Intermac, which is F9, and then another menu system appears. We select F18, which is a command for resetting, and we press the key that's directly underneath F18. Then we press the key again for F18 all. The machine has 3 axes, X, Y and Z, and all of them have to go to 0. So once we press this, the head of the machine moves, if you look now, and it goes to its 0 position. Okay? Again, we read the top of the screen and it says put selector switch in automatic. That means press this key here, auto. Okay? Now once the machine's been turned on, it asks you to do a spindle cycle. This is a function that warms the drill up of the machine before you start work. So basically it's not starting with a heavy load on it with a cold motor. We make sure that Y is activated up here and we press enter. Okay, now if you look at the machine you'll see that the spindle drill is spinning and also the external water and internal water is turned on. Okay, now the key here, F10, circles the blue line on the menu system. So if I press it, I don't know if you can see that there, the blue line is changing through 3 different bars, yeah? If we move to the top bar, we'll see next display. And if we want to see the next display, we press the key directly underneath the function. Well, just let's go back to that one. So we press F6, F6 again, and this is our main control panel page. The letters on the top left hand side, X, Y, Z and P, relate to the axes of the machine. X is a big axis that moves the head of the machine across the bed of the machine. Y axis moves it from front to back, and Z axis moves it up and down. P relates to the carousel for the tool change, where you store all your tools. Okay, these are the positions where the head of the machine is at the moment. So everything is at 0 because we've just done an axis reset. Later on, when we program a job, the coordinates of where it's going to will appear here. Okay. Now these three functions below, the first one is spindle speed. This is how many revolutions per minute the drill is actually spinning. Okay. And because we're at the moment conducting a spindle cycle, it's spinning at 3,750. It will go up to 10,000, and it takes about 10 minutes for the spindle cycle to complete. The next function, indicated by an F, is feed rate. This is how fast the tool moves through material. Now it's important to understand the difference between F feed rate and rapid. Rapid is the speed out of material. Okay. Now what I mean by that is that a router maybe cuts at 200 mm a minute inside the stone, but when it lifts out of the stone and it goes for a tool change, it changes from this speed to this speed. This speed is the speed out of material, which is 60 meters a minute. Okay, so it's very fast. And dangerous, yeah. Okay, the next function is ACT and NXT. When we're using the machine, ACT is the actual tool in the head of the machine, and next to that will be the name of the tool. Next to NXT will be the next tool that it picks up within that program, and underneath it'll give you an indication of its diameter and its length. Okay. This section here indicates what program you're running. You can see at the minute we have what we call ISO code, which is the language that the machine understands, and it's saying what line it is on in the program. It's just an indication. I don't expect you to know this. Okay. Okay, the spindle cycle is now finished, so now we can move on, and I'll explain the functions on the manual section of the keyboard. Basically, if I press manual here, I get a blue band at the top of the screen. Okay, this indicates what axis I can move. Basically, the cursor keys down here, I can choose which axis I want to move. Now, if I'm on X and I want to move across the bed of the machine, okay, I first have to select it blue here, okay, and then these two buttons here is jog direction. So we have plus and minus. Now all CNC machines relate to the Cartesian graph, okay, and Carlos here is getting us a demonstration of the Cartesian graph. Okay. When we reset the machine in the morning, the head of the machine goes to this position here, which is 0. Okay. Now, in real terms, our actual machine is in the lower right-hand quadrant of the Cartesian graph. So, in theory, our machine is here, and the head of the machine is in this position. It's at 0. Okay. Now, if I want to move the head of the machine across the bed, I select manual, which is here. I activate the X-axis with the blue band, and I select my direction. Up here I have plus and minus, and if you see at the top of the screen here, it changes from plus and minus. If I want to move the head in this direction, I must be in plus, okay, because I can't go this way, because I'll be off the bed of the machine. Okay, so I select plus and then I press the green button, and if you can see up here, the coordinates on the x-axis are changing. It's now 305mm from 0. Okay, I can do this with every axis, and I can relate it to the Cartesian graph. For instance, if I want to move the head of the machine towards the front of the bed, I change to the y-axis here, and I can look on the Cartesian graph and the direction must be minus. So on the direction buttons I activate minus. I see up here that it changes to minus, and I press the green button. And now you can see the coordinates of y-axis are changing. Okay? If we want to take a look at the position of the machine now, you can see that it's not at 0 anymore. The head of the machine now is 300mm from 0, and it's also about approximately 500mm from 0 towards us at the back. I'm going to go to the control panel now and send it back to 0 so you can see the position of where 0 is. If you'd like to take a look at how the head of the machine moves, and I'll send it back. When you first turn on the machine in the morning and you activate the F18 menu, this is what happens. This is where the head travels to and where it stops. Basically it hits some switches, the switches activate so the machine knows that it's at 0 and it knows where to count from. Okay. Right, if we go back to the control panel, you can see now that the head is back at 0, X0, Y0, for instance. Okay. Now that was by using the manual function. And you notice there, I selected the direction, I pressed the green button, and the head of the machine moved. But what we call that in the business is Jap Sniper. It only moves as long as I hold my finger on the button. Okay? If we want to be a little bit more accurate, we select the second function on the manual section, which is this one indicated by a hand and 2 arrows. This one is what we call jog incremental. Okay? When I select jog incremental, I can again choose the axes. But with the incremental button selected, I have another section here which is jog incremental plus or minus. If I press plus here, you'll notice in the middle of the screen these digits going from 0.1 up to 10mm. And I can also activate 1mm, 0.1, 0.01. Okay? As an example, I'll set it to 10. I'll select the y-axis and I want to bring it forward 10mm. So I select my direction, which is minus, as of the Cartesian graph, and I press the green button. Now if you watch the y coordinate here, you can see it's moved exactly 10mm. Okay? For as long as I've held my finger on the button. Okay? If I want to move it 1mm, I again activate the jog incremental button to minus, and it goes to 1mm. If I press the green button this time, you'll see it's at minus 30 at the moment, because the last time I pressed it 3 times. If I press it again, it just moves 1mm. Okay? And you can do this for every axis and every direction. Okay. So we've covered manual, jog incremental. This button we don't use. This is for 0 globe, but there's other ways to do it. So we don't use this key. We've explained jog direction plus and minus, and we've also explained jog incremental plus and minus. The last 2 buttons on the display are jog feed, and this is the speed of how fast the machine travels in jog. So I'll just select manual again, and this time I'll move it to the x-axis, and I'll select positive direction. Now if I hold my finger on the green button, it moves at a certain speed. If I press the minus button, it slows down. If I press the positive button, it speeds up. And that's indicated here by manual, 62.5% it is at the moment. Okay? So that's the function of this whole panel. So we have manual, just to move the machine basically out of the way of anything. Incremental, to move it more accurately, either 10, 1 mil or 0.1 millimeter. We have the speed of the jog, incremental movement of the jog, and the jog direction. Okay, any questions? Okay, right, good. Right, that's the manual section. On the automatic section, we press this button here and it activates auto. The main function of auto is to access any menus down here on the soft keys. For instance, any menu under the Intermac logo. Okay. This button we don't use, but this button is very handy. This one is MDI, which stands for Manual Data Input. On this key, when we press it, a green band appears at the bottom, and we can tell the machine to do something in its own language. Its language is ISO code. Okay, so for instance, if we wanted to send the machine to a certain location, we can type in that information directly. So we can go X1000, for instance. We press enter on the keyboard. The enter button is this one here and not this one here. Okay, so we press enter. Hold on. We press enter and then we activate the green button. Okay, and now you can see here X is exactly at 1000. Okay, we can put X1000, Y minus 1000. Press enter and green button. Okay, and now you can see on the control panel here there is X1000, Y minus 1000. If you want to take a look at the machine, you can see the exact position of the head now being 1000 or exactly 1 metre away from zero. We can tell it to do other functions, not just positioning. We can tell it, for instance, M7. M7 is a command for turning on the internal water. The internal water is the water supply that goes through the centre of the drill. And this is internal cooling for your tools. Okay. So I press M7, I select enter and the green button, and now you'll be able to see fresh water coming down through the centre of the spindle. Internal water. We press what is known as the flying hamburger, which is the reset key. We press that one and it turns off the M7 command. Another useful function is M8. We type in M8 here, press enter and the green button, and now you'll see the external water coming on. The external water is the recycled water system that comes from the tanks underneath the machine and goes onto the outside of the tool from the orange jets on the head of the machine. We can type in M6T. This means pick up tool. For instance, as an example, we're going to pick up tool number 2. But tool number 2 doesn't live in position 2. For some strange reason it lives in position 1. But that's because that's the name of the tool, not especially where it lives. Okay, so we'll type in M6T2, we'll press enter and the green button. Okay, so that was how to pick up a tool. To put away the tool is quite simple. We type in M6T0, okay, which means pick up tool 0. 0 is nothing, so it just puts the tool away, okay. So we press enter to turn it white and the green button again. Okay, so that was MDI. We can tell the machine functions in its own language of how to perform. The keys underneath is rapid, feed and speed. And as I previously explained, speed is the spindle speed in RPM. Feed is the speed of the tool through material. And rapid is the speed of the machine out of material. So for instance, on the last example that we did, the machine was out of material. We picked up a tool, we put a tool away. To control that speed, we use these keys, rapid, okay? And if I press a plus and minus here, you'll notice in the centre of the screen, the rapid speed goes down by a percentage, okay? And we can do that with the tool when it's cutting in material by feed rate. There's no tool there at the moment, but you can see the percentage feed going up and down there, yeah? Okay. And also for spindle speed. Okay. Usually I tell people that these three always 100%. Because we get the tooling information from the manufacturer of the tool. He recommends what speed and feed rate to run that tool at. And if we're cutting stone, if you alter these, you stand a chance, if you don't know in particular what you're doing, of making that tool blunt. So basically, when you come to operate this machine, check speed, feed and rapid is all at 100% underneath. Okay, so that was the automatic functions. We have three keys underneath. The first one is reset that we've seen, that we can deactivate a function. For instance, turn off the internal water, turn off the external water. We can also reset programs from this. So if we're in the middle of a program and for some reason we want to stop without pressing the emergency, we just hit the reset key and it brings it out of program. The green key is what we call go, and this is to activate the MDI commands only, okay? And then we have the red button here, which is pause. You can pause it like a VCR, so if the machine's in program, you press it, the red light comes on, the machine stops, okay? If you repress it, the red light goes off and the machine carries on. So it's pause. Sometimes you might just want to check that the tool's in the right position, so you press this, open the doors, have a look, close the doors, and then press it again, and the machine will carry on. Okay, so we've covered those functions. On this particular controller, these functions are not active for anything. It's only in this panel and these keys underneath. Now these keys underneath we've had a look at earlier. F4 changes the page. Okay? And each one of the F5 to F9 keys activates the function under which the blue line is highlighted. Okay? F10 enables you to scroll through those functions. Now, all the functions that we use are under the menu Intermac, so we'll have a look at those. So we'll scroll to Intermac and we'll activate by pressing F9 underneath. Okay, we've already seen F18. F18 is what we do every morning when we turn on the machine to zero the axes. SYS stands for systems. This is where we run our program jobs from. F19 is machine data. Important, don't go into this one unless instructed to do so by somebody like myself, because this is all the coordinates for where the machine picks up tools, for its speed, for everything. You can cause a lot of damage by going into this one, so don't go.
Don't use it, F19.
No, unless instructed to do so. F23 is for a device that we call the probe. The probe we can use to scan templates and also measure the thickness of materials and the heights of suction cups. Okay, then we have F24. F24 is the tool table, which is what we were talking about earlier on. If we just have a look at F24, I'll press the key underneath F24 to activate it, but it just goes yellow. That is because any functions under Intermac, you have to first press the automatic key, okay, before it will open. Now, in F24 is the memory of all our tools. and all the parameters for those tools. And inside F24 there is the capacity for storing 250 tools with different parameters, different heights, diameters, everything. Okay. There is one drawback: you cannot use tool number 1 because this is designated for the probe, and this is a tool that we use for scanning templates. So we don't alter that one at all.
Right, and we have a probe here.
Yes, we do. Okay. I'll just give you a brief overlook. We'll look at this in more depth later on. But if I wanted to look at a parameter for any tool, I type in the name of it. We've already picked up tool number 2. So I press 2 here, and then enter. I press enter again, and this is a tool that I was using for tests to pick up and put away. Now you can see here that the tool code, this is its name. Okay, so it's number 2. Okay. What type of tool it is? It's a mill. So if I press enter, I can go down the parameters. If I was to put a different tool in, it gives us a list of what number to write in for different types of tools. So we have diamond wheel, polishing wheel, mill, drill, all the different kinds of tools that we use. Okay, notes, this is just a description of what we call the tool. For instance, 16mm router or 35mm drill or whatever you want to call it. If I go down again, you can see that the name tool 2 actually lives in position in the tool rack number 1. Okay, and we can change that, we can put it anywhere we want, so long as we know to change it on the machine as well, because just changing it here doesn't change it in its physical holder. Okay, right, the other parameters we have height, which is the length of the tool. We have its radius. Vertical offset means we can lift that tool up and down on the material. Say we don't want it working at its correct height, we want it working at a different height, we can put in an offset. Band of oscillation is what we use for routers. Rather than cutting straight through the material, say we have 50mm of diamond and we're only cutting 20mm of marble, we can actually move the router up and down on the edge like this, so it uses all the diamond on the tool rather than just using the bottom 20mm part of the tool. Where are we up to? Right, okay. Now, anything with preset in front of it means an automatic tool measuring device. Unfortunately, your machine hasn't got one, so you have to use a device like this, which is a vernier caliper for measuring all your tools. So whenever you come in here and you see any item with preset written in front of it, just ignore it, because you don't have that function. Okay. Right, we'll get down to this one now, parameter 18, which is tool working capacity. This is how long we expect the tool to last. For instance, if you have a router and usually it burns out after 300 metres, yeah, you can write in here 299. And when it reaches 299 metres, the machine will tell you to exchange that router and put a new one in. Okay. We have distance travelled. When it's a new tool, it'll be at 0, and every metre it travels, it'll count for 1 metre. So you can judge up to this one how much life you've got left in your tool, basically. Alternative tool, this means if you have 2 16mm routers in, and the first one gets to 300 metres, it knows not to use this tool, but to use your other 16mm router. Okay, and it'll do that automatically. Maximum spindle force, nominal spindle force and range top limit all apply to this little clock here. As I explained before, this is RPM and this is an ammeter. This tells you how much power is used on the spindle. Every tool uses different amounts of power. Routers use more than profiling tools, or some profiling tools. Polish wheels use different power again. By these 3 functions here, we can put in a value that when this clock reaches that value, it makes a change. For instance, maximum spindle force for this particular tool is set to 30. If this clock reaches 30, it'll stop the machine. Because it'll think, well, I'm not cutting limestone anymore, maybe I'm cutting through a suction cup. So that's quite a high power rating. The next one down is nominal spindle force. This is what we expect the tool to do. So when it's new and you cut your first piece of limestone, you'll get a figure here, okay? That is the figure that you put in here for nominal. The next one is range top limit, okay? And this is usually a little bit more than your nominal. For instance, normally about a third again. Because after the time the tool's not new anymore, it starts to wear and it is going to take a little bit more power for cutting. So what will happen is this one's set to 12. When the clock here reaches 12, instead of it stopping the machine, it'll adjust its feed rate, which is its speed through material, until it gets back to 8. So it's protecting your tool basically for unsightly wear. And those are all the parameters within F24. To exit out of F24, you scroll through the list by pressing the Enter key. The last one says confirm yes, and then it says 0 to exit in yellow. So you type in 0 and enter, and that brings you out of F24. F25 now. This is origins. And it all relates back again to the Cartesian graph. As I explained to you before, our machine is in this lower quadrant of the Cartesian graph. But when we make our drawings are in the top right hand quadrant of the Cartesian graph. And the bottom left hand corner of our drawing is at 0. Okay? So F25 gives us the option of moving from the top right hand quadrant to the bottom right hand quadrant. Okay? And we do this by selecting an origin. Previously this machine's been using origin 1 as X131 and Y minus 1086. Okay? So if we select origin number 1 on our program, from 0 on the graph, it's 131 down here in X, yeah, because X is across, and in Y minus it's 1086. So it's somewhere like that. And where those two lines cross, it knows there's a 0. So really, it's offsetting your drawing from here onto the bed of your machine. In F25, we have 10 origins that we can use. Most people only ever use one, and they set that machine up, and every time they do a program, origin 1, because that's the biggest area for the biggest piece that they can possibly fit on the machine. Okay. 0 to exit out of F25. And we're back to our normal page. If we use F10 again, we can go to next and press in F9, and in here we've got more Intermac functions. F26 is interesting because you can change the language. Portuguese might be handy, I don't know.
That's perfect. We're carrying on in Portuguese. That was the icing in the cake, isn't it?
Okay, so that's F26 languages. F27 is spindle cycle. Maybe during the day you'd like to run another warm-up cycle, so you'd select F27. F28. Oh. That's it. This is an important one. Every week you must back up your machine data, and this is where you do it. You go into F28 and you put a floppy disk in this guy here, and you'd select number 4, all data, press enter, and it'd write all the machine information onto a floppy disk. So if one day you come in and you turn this on and there's nothing in here, you have the information inside your floppy disk.
Do you think we can still find flop disk to buy?
Okay. That's F28. The one next to it, F29, is reload data. So if you've made your backup and you've come in and you've lost all your tool data, the machine's not picking up from the tool, you can reload your data, type in number 4, put your floppy disk in, and it'll read all the information from that floppy disk. Okay. Laser you don't have. That is a 3D scanner for making, I don't know, fireplaces, marble bus, something like that, pictures, and it'll carve it out three-dimensionally. F30. Okay, this tells us how many hours the machine's worked, what software it has. Again, it's more for engineering purposes than user purposes. Okay, and that's all the F functions. Okay.